The basic mechanism of how carbon gets into soil is through photosynthesis. So again, if you see a bare field, there's no photosynthesis happening. So there's no carbon like going into that soil.
A bare field meaning just like no grass, no plants?
Yeah, just nothing, like a tilled field.
Okay.
Yeah, if there's grass, like there's photosynthesis happening for sure. Or even if like out our back door where there's like, where they've excavated, like definitely no, like there's carbon loss. So when photosynthesis happens, we, going back to grade school, like we know that a plant takes in CO2 and sunlight and takes up water through its roots, and then some magic happens and you get plant sugars. What they don't tell you in third grade is a lot of those sugars are released through the roots. Like sometimes it's been recorded up to like 80% of the sugars are actually released through the roots. And that's really surprising to people because it's like, well, why would a plant do that? Doesn't it want to just use those sugars for its own makeup, its leaves and its fruit and its roots? And the answer is because they're feeding the microbial ecosystem below ground. So they're actually exuding sugars and other compounds to attract the beneficial microbes that they evolved over millennia with to keep them nice and close to their roots because they provide this symbiotic relationship. So it's a transaction. I'll give you these sugars that you like so much if you give me phosphorus that I need.
Okay.
That's the basic principle. And so carbon's journey, I'm going to take it one step further and you tell me if we've gone too far, but that basically is just like the sugars are coming out of the plant, but it doesn't just like sit in the soil. A microbe will come along and consume it, and then that microbe's like embodying that carbon. So it becomes part of its makeup.
Right.
And I think where I might start losing people is when we go back to something I said earlier, which is respiration. Like bacteria respire like we do, so do fungi. So that means they do release CO2. So the question is like, well, what the heck? Like, how does carbon stay in the soil? And it's really a matter of ratios. Okay, so let's say you have of all of the sugars that the plant is putting into the soil. When a bacteria comes along, it will respire up to like 80% of that carbon. So it's only retaining about 20%, but that's still a net gain into the soil. You're still keeping some carbon into the soil. A fungi, on the other hand, is like the opposite. It blows off roughly 20% of carbon, but it retains 80%. And when you think about, because it's a more carbon-based organism, and when I say fungi, I'm not talking about mushrooms. I'm talking about like the mycelium in the soil. That's actually the body of fungi is beneath the surface where we can't see it. It's like these long filaments. And so the surface area on those is important because it's kind of like, when they give you a stat of like, if you stretched this, I'm going to use mycelium as an example, but they do this with other things that have high surface area.
Like veins or something in your body.
Yeah, veins. Yeah. If like, that's a great example, like capillaries and stuff in your body. It's like, it'd stretch a mile long.
Right.
That's what high surface area does is like, it's actually a lot of material, but it can be fit into a small space. And so fungi is the same way where like its amount of carbon that it can contain is really significant. And again, if we disturb that ecosystem, what did I say gets kills off first?
Yep.
It's the fungi, and so that's why we actually lose a lot of carbon from our agricultural lands because of all the disturbance. So we're doing like the opposite of the thing that soil is supposed to be providing, which is carbon sequestration. So I'm going to stop there and check in, like, how are we doing on that?
No, that makes sense. So carbon helps keep. I'm trying to play this in and refer back to your article, but when we disturb the land, carbon gets released, and then that's basically like heat emits off the carbon. Is that?
Oh yeah. Okay. So let's talk about like why carbon in the atmosphere is just not a good thing.
Okay.
So the actual shape of a CO2 molecule, I'll just kind of draw it for you real quick. You got like, imagine almost like a triangle. So this is the carbon, and then you have 2 oxygen coming off of it. Does the camera need to see that?
Yeah, you can point it at the camera. Do a little carbon action.
CO2. So what's happening there is the actual shape of that molecule when it's in our atmosphere reflects heat back down to us. So let's back up real quick. We gain heat to our planet from the sun. Okay,
Right.
So the sun is radiating light. The light is what the energy is, and then once it hits the surfaces of Earth, some of that's absorbed, but then some of it's like at capacity, and then it's radiated back. So there's almost like this reflection of radiant heat, but then it interacts with things like CO2 and methane, and that's gonna keep like trap the heat. So it's not if the CO2 and stuff wasn't there, or other greenhouse gases, then it would just escape into space. The radiant heat would escape into space, and that's essentially what happens during like ice ages and stuff. Is like our atmosphere isn't able to retain heat well enough, so there's a lot of heat escaping, and then we go into like an ice age. So we do need a certain amount of CO2 to maintain the environment that is good for humans and so much other life. But when you overdo it, when you have too much CO2, and then we're just like baking ourselves in this greenhouse.
Okay. So that's why disturbing the land is putting more carbon into the atmosphere, which is essentially making it hotter. So when it's talking about global warming, that's basically what it means.
Yes. And I do want to point out that like conventional agriculture methods are a contributing factor to CO2 release, but the biggest one is going to be burning of fossil fuels. So, fossil fuels come from deep within like a soil system typically, and those are old plants and animals and stuff that have died and decomposed, and so they're carbon-based animals. That's
right.
And then they're basically fossilized, but into a form that now we found can generate energy. And so, but every time we burn that carbon, we're now releasing it into the atmosphere. And so there's those, I would say, are like two major ways carbon gets into the atmosphere. Some people, it's kind of a myth that like our population is too big. I wouldn't go around like feeling guilty about exhaling.
Yeah, like hold your breath.
Yeah, like that's going way too far. But because like the amount that we've burned is like way more. It's kind of like before anthropogenic sources of carbon, whether it was coming from agriculture or fossil fuels, would have been like volcanoes, like things that took all of that matter like deep within the earth and released it into the Earth's atmosphere. And so I think it's kind of fun to think about like when you see a car go by, just like imagining like a little volcano like in the back of like every truck or in the seat of every car that you see, because that's basically what we're doing. We just have all these tiny little volcanoes going off like every second of every day.
Does the carbon that gets released from the earth, does it ever get put back in the earth? Like how is there a cycle that can be done to put it back in?
Yeah, so the two major sinks are going to be soil and the ocean. And technically the ocean, like that, they're both part of the carbon cycle. Like carbon will go into those systems and maybe exist there for a little bit and maybe be released, So I always say like, it's not that we're just trying to get carbon in and that it's going to stay there. It's kind of like we just want the soil to be a popular stop in the cycle, because then that means that we're generating more and more carbon like in the soil. So one thing real quick about oceans is like technically it's a bigger sink. Like there's more of our planet that's water than land. But the implications of CO2 increasing in an ocean atmosphere or an ocean environment is detrimental from what we know. Like there's actually a lot that's unknown, like how much CO2 can the ocean handle without having like a mass extinction?
Because it heats up the water?
It's more of like a pH issue. Okay. And then also the heating of the environment causing like the icebergs and glaciers to melt is a huge problem that we're already seeing in the sea level rise. But it's more of like a pH issue that people are concerned about, as like ocean acidification, and how like the implications that's going to have on ocean life. And so what's really cool is like we know that the increase of carbon in our soils is a really good thing. And so it's a bad thing. It could potentially be this really bad thing for oceans, or we're not really sure. But we do know that like to increase carbon in the soil sphere is a really beneficial thing for us.
So some quick things that can be done, I say quick things, but some smart things that can be done to speed up the process of soil coming from the atmosphere into the soil is regenerative farming. I mean, what are some other things?
Keeping your soil covered. So whether that's through vegetation of some kind, like your turf is actually better than gravel. So I might irritate some people saying that, because they might think that they're doing the right thing by having like a xeriscaping. And I'm not saying you're doing the wrong thing necessarily. There's like all sorts of different contexts, but that might just be a practical thing to mention, is that like if you're tempted to take out your turf and put in a bunch of gravel, just consider that like you're kind of sterilizing that environment. Even if you put some plants in, it's just not as vegetated.
Is that soil sealant, or what is it called? Soil seal?
Oh, soil sealing.
Is that what that is when you do that?
Yeah, because it's an impervious surface. Rocks, yeah, in theory, they're going to break down over time and mineralize, but not like mulch. Okay, so mulch is a way better way to make a path on your property. And yeah, you're going to have to top it off every now and then because it's freaking degrading, which is like what we want. So when you're mulching your trees, or you're like, slugging out all these bags and stuff, like that's actually a really beautiful thing that you're having to top off, because like my husband asked me, he's like, so where does the mulch go? And I was like, yeah, it's like degrading. Isn't that cool? Like, he's like, I just don't understand. Like, it was just there. And I'm like, yeah, I know. It's like feeding the ground, feeding all those organisms we're talking about. So mulch is a great way in times where like your plants maybe are dormant. Cover crops are another really great tool. And they're not just for farms. Like, I'm thinking about using a cover crop in areas where grass doesn't grow very well in like shady parts of our yard.
Right.
So yeah, keeping the soil covered in one way or another is like one of the most important things you can do as a citizen of the world, even if you're not a land steward per se.